Welcome to BC Mnemonics. In this video, we're going to be taking a look at the Crescent Dial, a very unique form of equatorial dial. So before we begin, it's worth clarifying that this dial has a very unique feature that most Crescent dials have, which is the central equatorial ring, characteristic of equatorial dials, is split and reconfigured into two dial faces, one used during the morning hours and one used during the afternoon hours. And because there are two hour scales, there are also two notices, the tips of the titular crescent. Now, to use this dial, the first step is to incline it to the latitude of use. So here we have 90 degrees, which means this dial is ready to be used at the North Pole. As you can see, the equatorial scale sits parallel to the local horizon, and the celestial axis, perpendicular to that, points 90 degrees up. If we set it to the other extreme, the equator, we have the dial ready to be used at that location, which entails the celestial equator, or celestial axis, being 0 degrees up from the horizon, and the celestial equator being 90 degrees above the local horizon, indicating that the sun rises 90 degrees in the sky and passes through the zenith on the equinox. At the summer solstice, the dial is set quite close to the summer solstice right now, as seen by this notice. The sun will arc still 90 degrees in the sky, but a little bit north, not quite through the zenith, not setting due east and due west, rising due east, due east, setting due west. But now let's set the dial for our actual latitude, which is 44 degrees. Right there, 44 degrees. Next step is to set the date, and I teased this a little bit earlier, but the date setting results in the setting of both notices at the same time. One thing you have to keep in mind is that this particular dial, at least, has a bit of wobble to its notices, and so you do have to make sure that they remain symmetrical with respect to the celestial axis. As you can see on the equinox, these notices will remain right in line with the equatorial band, and at the summer solstice they're positioned quite a bit above it. Today's date happens to be very close to the summer solstice, so we will position this screw right about mid-June, which is today's date, June 13th. A little bit higher, actually. There we go. And making sure that the crescent is symmetrical. Yeah, that should work. So now, the only thing left to do is to position the dial on a level surface. And this can be done in two ways. In some cases, the dial will feature a plumb bob. In this case, the dial features a bubble level that, as you can see, is able to rotate. Although because I'll be handling the dial, we won't really have to worry about a level surface right now. But the last step, and perhaps the most interesting, is orienting the dial true north. Now this can be done two ways. If you don't have access to sunlight, or if you simply want to use a compass, you can. You can use a compass just like any other stationary dial, and this dial will be ready to go once there is sun. Worth noting that this is the northern side. But if you don't have a compass, or if you'd prefer to use the self-orientation method, getting true north directly without having to worry about magnetic declination, you can. So this dial is able to self-orient in exactly the same way as the equatorial ring dial. And as you can see, its notice, the position of the crescent dial's notice matches up exactly with that of the equatorial ring dial. Now, there will be a separate video explaining exactly how this self-orientation works, but for the purposes of this demonstration, the procedure is all we'll be covering, which is, again, as I said, exactly the same as the equatorial ring dial. So you'll rotate this dial with it on a level surface and wait until you see the tip of this notice, tip of this crescent, so the notice right here, appear and reach the center of the hour scale. Now, when the notice is resting on that center line, that is either telling the correct time, or that may be indicating the second position, the second possible orientation, which is the incorrect time, which is the same solar elevation as the correct time, just mirrored in the other half of the sky. So for example, 10 a.m. and 2 p.m. had the same solar elevation. It's just that at 10 a.m. the sun is in the eastern portion of the sky, at 2 p.m. the sun is in the western portion. Those shadows on the dial will look identical if you don't know either the rough direction of north or the rough position before or after noon. Let's just say that we're using this in the afternoon, and so we know that in this example, 2 p.m. would be the correct time. If we rotate this dial and we see both 10 a.m. and 2 p.m. lining up, we'll simply select 2 p.m. Now, the way the sun interacts with this dial is a bit unique, just by nature of it having two split hour scales. So in the morning hours, the sun rises in the east, and so the notice will trace down the scale. Again, the notice always moves in the opposite direction of the sun. So as the sun rises, the notice will proceed down the scale. And at noon, when the sun is due south, the notices do not cast shadows on the scale, instead passing right by it. But as the sun proceeds into the western portion of the sky, this notice will take over the job of time telling, and its shadow, its tip, will begin to rise up its scale as the sun sets. Now, I hope this demonstration was useful, and thank you for watching.